Good morning, YouTube, and welcome back. So, in the last video, we went over all this stuff in like 30 minutes. So, I think we're going to kind of move on. So, in this video, I wanted to focus on data types. And I wanted to break these down. I would have written them all in here, but it was, it's quite a bit on here. So, the very first thing I wanted to go over is an actual value type, which there's quite a few. So I'm going to do regions for all these. So there's true and false. So we all know true or false. But what you might not know is that 1 is true and 0 is false as well. So to signify whether something is false, bool is your true or false keyword. Not boolean, but just bool. So bool t can equal true, bool f will equal false. And if you would type in 1, there's an error. And I'll end the region for this. So bools are true and false. That's just a true or false statement. To show you, we can write to the line but what I'm going to do is I'm going to do a conversion real quick. You don't have to really remember this. I don't have that initialized yet, so int num. I'm going to convert to int 16 because it's small. I'm going to convert a bool to a number, and if I hit start, as you can see, it shows up as 1. If I converted f, the false statement, it returns a 0. Now, what if, well, we're not going to convert backwards. Okay, so just remember that bool is true or false. Alright, now the next one are going to be integer types, aka numbers. And this is when it kind of gets long. So I'm going to do that one next. Getting ahead of myself. Let's do a we'll do a 16-bit Unicode character. Now the 16-bit Unicode character you really don't have to remember. Because all a character is, ch, is exactly what it says. It's basically a character on your keyboard. So character C can equal, you do the single quotes behind this, can equal J. Or it can equal 1. Or it can equal the number or the $sign. But it's only a single character surrounded by a single quote. So I'll put that into the region here. Single character on keyboard encased or enclosed in single quote. I'm not sure what the single quote is called. And I'll put those around double quotes. Okay. I can't remember how to do it with actual stuff, but what I can do is I can do it's a U plus four zeros to U plus 4F. So any character that represents those characters. And I wish I could tell you exactly what these are, but I don't really remember. But really all you have to remember is that it's any key on your keyboard, basically. You know, A through Z, 1 through 0, or 0 through 9, minus, negative, or minus, slash, underscore, the @ symbol, everything. Okay? Integer, almost knocked my keyboard off my lap. Integer or integral. There's different types here, and these are all going to be under comments. We have I'll go the ones that start with 0 first. So these are going to be starting with 0. So a byte, and I'm going to go b min for minimum, equals 0, because if you do a -1, it won't work. Okay, so it starts with 0. Byte b max equals 255. So bytes range from 0 to 255. Then, if we move on down the list, we have a U short. I don't know why I capitalized the S. And I'll go U min equals 0. Let me go ahead and come up here and you stop that. And I'll type in the signed integer. So this is an 8-bit unsigned integer. Unsigned basically means that it starts with 0 from what I understand. This one here is a 16-bit unsigned integer, and the max for this equals 65,535. Now, to show you that it can't go over, if we put a 6, there you go. And a lot of these you probably won't even use, but they can save space. The next one is a 32-bit unsigned integer, which is a uint. So I'm going to go, actually this one should be usmin, usmin, ui min equals 0, and UI max equals a really big number, and I have it written down. Hang on. So it's 4,294,967,295. That's the max it can go. Sorry, you guys can't go any further. And that's about it. You can't go any number higher than that. No, I'm kidding. Obviously. See? 96 doesn't work. Then we have a 64-bit unsigned integer. So I guess these would be used like if you're trying to check to make sure something doesn't go negative without using, well, you'd still have to use it. No, you could use a try, but yeah. 64-bit is a little bit longer. Of course, the minimum is 0. And I really don't want to type this in. I really don't want to say it. But I'll give it a go. Let's see. Hundreds, thousands, millions, billions, trillions. Another one and another one. I don't even know what those are. Well, it's 18 something, 446 something, 774 trillion, 73 billion, 709,551,615. Don't tell me that one's wrong. What? Five 116 155 907 907 370 370 477 477. Oh, my bad. So yeah, it's that number there. So you can kind of see how big the number is. It's pretty big. And that's it for the ones that are starts with 0. Then we have the whole numbers that start with a negative and can go positive. So whole numbers that start that can have a negative number. Okay, so trying to find okay, there we go. So an S byte, SB, or yeah, SB min can equal a negative 128. Can't go any lower. And S byte SB max is 127. And this is an 8-bit signed integer. This next one, obviously, is a 16-bit signed integer. Oh wait, no it's not. Never mind. Take that back. It's a 32-bit. So this is a 32-bit. It skips 16-bit for some reason. Oh no, I was right. It is a 16. I was just looking at the wrong one. Yes, I have this written down. These numbers aren't exactly right off the top of my head. This is called a short. So short SH men equals a whopping negative 32,768. And a short SH max, can you guess it? It's 32,767. Because it's always 1 minus, because of 0. The next one is a 32-bit signed integer. This one is the all-famous int, the one everybody will be using all the time until you get into really, really big numbers. Not max, I want min. Equals, and this one is trillions, so negative 2 trillion, 147 million, or sorry, billion. So negative 2 billion, 147 million, 483,648. Then we have the int I max theater, which can seat a whopping 2,147,483,647 people. It's a big IMAX theater, isn't it? Okay, next we have the 64-bit signed integer, which is a long. So I'm going to go Lmax, or Lmin, which is another one of those giant numbers, which I'm not going to be able to read. So it's 9223337. Okay, well, anyway, it's a 9 something, 223 something, 372 something, and 36 billion, so 372 trillion, 36 billion, 854,775,808. So a long Lmax equals this number minus 1. I have an error somewhere. Where do I have an error at? Down at the bottom. How do I have an error there? What? Oh, I'm missing an... But I have... Oh, I'm missing an end here. My bad. Okay. So that's it for those, I believe. Yes, that's it for those. Now we have the ones I never use, or I do, but hardly ever. I don't even know really how to write these, because a calculator won't even write them. I'm going to figure out the lowest number on this real quick. 4. So the first one that we're going to write is going to be kind of a little special one here. These are decimal numbers that can have a negative number. The first one is a 32-bit single precision floating point number. Okay, so I'm going to write a quick little code thing here for float FL equals 0. FL minus minus. I don't know if I can do that or not. I think I'm missing something. Cannot implicitly convert type FL to bool. I know I have to have it equal to something, but okay, fine. I'll go FL is, while FL is less than 6.1. So while this goes down, so try console.writeLine FL catch float J equals FL minus 1, maybe? Console.writeLine J console.readKey. Yeah, that's going way too much. Oh no, it's gonna keep trying. Oh crap, I didn't want to do that. So let's go with, let's just float J equals FL J readKey start. It broke. Oh, that's right. Duh. Float J. Don't tell me that. apparently it's thinking. So let's do a float equals a minus, oh, let's see, 3.4, oh, the 2.4. No, let's go with 33. Yeah, let's go by the hundreds. Minus that number. I don't know. I don't really know what the... I'll just put these in parentheses, I guess. You know, they say that a good programmer should be good at math. I suck at it. So I guess I'm not good. So a float, and I'll just put FL min equals a negative 3.4 times 10 to the 38th power. I'm going to look it up. 3.4 times 10. Where'd that button go? Well, that's nice. How about very large numbers? Very large numbers calculator. I don't want the expression. Oh, yeah, I do. Negative 3.4 times 10 to the 38th power. Sorry. Alright. Well, anyway, just know it's a really big number. So float FL max equals 3.4 times 10 to the 38th power. Big numbers. And the rest are even more confusing for me. So this one is a 64-bit double precision floating point type. I guess these are types, not numbers. Which is this one's called a double, hence the double precision. And basically, I think what this one means is that you can do a 5.66. And I'm going to try that real quick. I'm pretty sure that's right. So like a double D equals 5.66. Yeah, because if we do another 6, 6, 6, 6, 6, 6, 6. Okay, what if we do a float FL equals 3.4? Oh yeah, you have to put an F at the end. I forgot about that. So I'm going to go ahead and write down the min and max for these. So double D min equals plus or minus. See, I don't understand some of these. They don't make any sense to me. 5.8 times 10 to the negative 324th power. Double D max equals a plus or minus 1.7 times 10 to the positive 308th power. I really don't use these. I use doubles for small numbers, but I don't use them for nothing that big, so. And then the next one is a 128-bit precise decimal values with 28 to 29 significant digits. So decimal DE, we'll say des, equals, so I think what this is saying is that it can be like 1 point I was wrong. So anyway, decimal DE min, DC min equals okay, this is odd. So this is DC min and max. DC M and M equals, it is a negative 7.9 times 10 to the 28th power to 7 point, okay, so yeah, there's the minimum, and I'll get to the rest of what I'll go ahead and write it in, which can be 10 to the negative to 10 to the 28th. See, I don't go this big, so I don't really know what they're talking about. This one can be 7 point, and if anybody wants to write any really long numbers, go right on ahead. And it's the same thing, 10 to the 0 to 10 to the 28th. But that's it for numbers. Decimal DEC equals 6.5. D. Or not D. D. Where does it go before it? I can't remember which one it does. I don't use decimal, I use double. M. It's M, everybody. It's M. Can you be lowercase? Yes. Okay. So it can be lowercase or bigger case. Yeah. Uppercase. But that's it for the numbers. I mean, there's, as you can tell, it pretty much covers everything. And there's even, I think there's even bigger ones than that. because I know this isn't the max number you can have. So, but that's it for numbers. Really? I should have read that first. So if I go console dot write line size of decimal console dot read key $16. Oh, that's not what that is. That's not what I was looking for. Alright, well, anyway. Then there are... So that's it for these. So that's good for true or false, 16-bit Unicode characters, and integral numbers. Next are reference types, and these are the ones that I use like literally all the time, and pretty much everybody in the world does. The very first one is an object. There's object, dynamic, and string. Object, to initiate, it's the ultimate base class for all data types in C#, common type systems. Okay? So it's boxing, there's boxing, and then there's unboxing. When it is converted to an object, it's called boxing. When it's converted to a value type, it's unboxing. So for like boxing, or okay, first we have to declare the object. So object obj. Then we want to box it, which would be obj equals 100. Okay. Unbox would be like int box equals obj. Well, int dot or convert dot to int 32. I think that'll work. Yes, that's unboxing. So basically, you can also do a, like, yeah. I mean, that's just, there's really no other way to explain that. So an object can equal anything. So it can be, I'm pretty sure it can be like that. Yeah. So it can be a string, an integer, anything. I'm trying to figure out exactly what they're exactly how to put it though. Okay, so an object can be assigned values of any other types, including value types, reference types, predefined or user-defined types. So it can be anything. So it can be any value type that we're basically going to go over. A dynamic type, you can store any type of value in a dynamic data type variable, which it's basically an object. I mean, if you really think about it. So dynamic you type in dynamic equals 1 or dynamic equals hello. So it's pretty much the same thing as... Okay. The only difference between these is objects are are checked while the code is running. Dynamic types are checked when the code is compiled. That's the only difference between those two. A string. So the string is the you can assign any value yeah, so anything like string str equals this is some code. It can be a string. Or you can go string equals 1. Well, obviously I can't call it the same thing, so string 1. So it can be anything. So string str2 equals the and sign. So like it can literally be anything. Now, whenever you get into things like the only thing you cannot use is whenever you're talking about I can't even think of it, like a directory. So string directory equals C:/ Windows. That won't work because this is the / is called an escape character, which if you've done anything like HTML or any other scripting at all, you'll know, like, I believe that is a new line. Then there's the N. So in order for it to look at it directly, you have to put another / in front of it. Or the easiest way to do it, instead of like, okay, say you were going to do C Windows / or not Windows, C users. No, that wouldn't even work either, would it? Let's find out. C drive. Yeah, Windows. And my dog's growling at something. / users. You can go at. I'll be right back. I need to go see what my dog's barking at. Well, that was fun. Well, I'm back. Let's see here. So, if you put the @ symbol in front of it, it looks directly at the string. it looks directly at this instead of looking at the escape characters, which is something we'll end up getting into a little bit later on. We're not going to get into pointer types, not yet, maybe later, because I think this is enough for right now. I'm sorry for boring everybody. I hope you guys maybe learned something. Let me know about these numbers up here. So that's about it for this one. Make sure you hit save as if you were following along. And that's about it. So if you want to see these keep coming, hit that subscribe button, like the video, and leave a comment. Tell me what you think. And again, if you have any ideas on a program that we should write, let me know. And I will see you in the next video.